All right, so here we are. We're on our note sheets. 4.1. Yep. I think this next period is the same thing. You're either first, second, any period. And it's first, second, or third. And it looks like it's half an hour. Yes, he's on. Okay, so here we go. Change the following degree measures into radian measures. Now, here, this is a foreign language to you. You're saying to yourself, what do you mean? Up to this point in your life, every time you have measured an angle, it has been probably in degrees. Think of geometry class. All the angles you did, they were in degrees. Well, you know how if I said to you, we're going to measure the width of this room, you could do it in feet, you could do it in inches, you could do it in meters. There's lots of units of measurement for length or weight or, whatever. Same with angles. Degrees aren't the only way to measure angles. Mathematicians, once you get to this point, to the trigonometry point, a lot of our work is done in a unit called a radian. Angles are measured in radians. So what you need to remember about that, very simply, is that pi radians equals 180 degrees, which means 2 pi radians would equal what? If 1 pi is 180, 2 pi's would be 360, sure. So that's a revolution. If I said to you, let's do a revolution, in degrees it would be 360, in radians it would be 2 pi. In order to convert from one unit to the other, it's very, very, very simple. I feel like I need a new marker to start the new semester. Don't you? Yeah. In order to convert, it's real simple. We set up a ratio. We say pi over 180 because of this relationship right here. So set up a fraction with pi over 180. That will never change. That's a fact of life. Pi and 180 are the same. Okay? So pi over 180. And then we're doing A. It would be x over 100. Because it says, how many radians is 100 degrees? So I know pi goes with 180. What goes with 100? That's it. That's all there is to it. Now I solve this. So I could solve it by multiplying both sides by 100. And now I'm going to reduce that fraction and I have my answer. It's that easy. So let's see. To reduce the fraction, I can get rid of that. Then I have 10 over 18, which would be 5 over 9. And there's the answer to the question. Marley?
Can't you just cross multiply?
You can, and then divide. You'll end up with the same thing.
Okay.
You absolutely can. Yep. Okay, so now we're going to do the next one. All right, now the next one says negative 60. So we're going to say pi over 180. And again, groupies, that will never change. You are always going to say pi is 180. Those match. Now this problem is negative 60. So I'm going to say x over negative 60. Now, you're not going to get confused, boys and girls. You're not going to say 60 over x. Because this 180 is the degree measure, right? So if 60 is a degree measure, it has to go on the bottom of the fraction. The degree measures are on the bottom of the fraction. Degree denominator. All right, so then I'm going to end up with negative 60 pi over 180, which again, I'm just going to have to reduce that fraction, so the zeros cross out. And negative 6 over 18 would be negative 1 over 3. Yep, 1 pi over 3. Now, I usually write it that way, If you would rather write it this way, that is fine. I usually just put pi over 3, but if you want to write 1/3, that is fine, 1/3 pi. Okay, try 210 on your own. See if you can get 210 done. You're going to do it exactly the same way. What do you think? I got 7 pi over 6. What about you? Anybody have a question about that? A problem? Concern? Everybody okay with that? All right, let's look at part 2 then. Change the following radian measures into degree measures. So now we're going the other way. Everybody see that? We're going the other way now. We can do it with this, but actually in most problems we don't have to. Let me show you. If we have pi over 4 as our radian measure, what if I just had pi? What would pi radians be the same as?
180.
180. So if I just had pi, it'd be 180. But I have pi over 4. So this is the same as 180 divided by 4. It's a fourth of 180. So a fourth of 180. Anybody know what that is? 180 over 4. What is that? 45? So the answer would be 45 degrees. Think about it now. A whole pi is always 180, period. Pi radians is 180 degrees. Never changes. It's like your mom loves you. That never changes. Pi is 180. Okay? If you have a fourth of that, then you just have a fourth of 180. So you have 45. All right, what about the next one? 2 pi over 3. Somebody said 360 over 3, because isn't 2 pi 360? So 360 divided by 3 would be the same as 120. These are easy if you remember one thing. Pi is 180. Negative pi over 6. What about negative pi over 6?
180 over 6.
Negative 180 over 6, which would be negative 30. 7 pi over 6. Oops, we just did that one. Let me erase this real quick. 7 pi over 6. Now, let me give you a little hint. Don't do 7 times 180 divided by 6. That's too much arithmetic. Do it this way. We know pi is how much? 180. Divided by 6 would be 30. 180 divided by 6 is 30. Times 7 is 210. So if you're not allowed to use a calculator, or if you don't have a calculator, always do that division first. Pi is 180. Divided by 6 is 30. Times 7 is 210. Marley, you okay? Yeah. Okay. Oh, shooty chooty. Look at E. What's different about E? There's no pi.
That's wild.
Then we got to do it the other way. We got to set up that proportion and say pi is 180 2 over x. Now, oh, Mrs. Ford, why did you put the 2 in the top? Because the 2 is the radian measure, and I am trying to figure out the degree measure. Pi radians, 180 degrees. Degrees go in the bottom. So pi over 180 equals 2 over x. Now I am going to cross multiply, Marley. So pi x equals 360. And I'm solving for x. So x equals 360 divided by pi. Does everyone recognize this is the same thing we did in part 1? Only we were solving for a different thing. Morgan.
Would it not speak to since pi equals 180?
Ah, great question, Morgan. This is a degree measure. And you can only change it to 180 if it's a radian measure. So we would just leave it as 360 over pi. That is a great question, though. Morgan is back strong.
Extra credit.
Probably not quite
That's
that
extra
good,
effort.
but it's good. Kudos. All right, how about the last one? Anybody who misses the last one ought to be kicked in the seat of the pants. Pi radians is how many degrees? 180. That's 180. Okay? Now, who's got a how many brought calculators today? Raise your hand up high if you got a calculator today. Okay, quite a few of you. If you do not have your, and I'm talking about now, a graphing calculator. If you do not have a graphing calculator with you today, I want you to sit next to somebody who does, because the next section is all about pushing buttons. And you need to be able to push the buttons. And kids, I know you're going to sit there and listen to me and think, oh, this is easy, and it is. But if you don't have a calculator, you're not practicing, you're going to forget this. So get by somebody who's got one and pay attention. We're going to start with 100.4 degrees. And we are going to change this into degrees, minutes, and seconds. Now, let me talk about that for a minute. Everybody knows angles are measured in degrees, or can be measured in degrees. Degrees can be broken up into smaller pieces. Just like a foot can be broken up into 12 inches, degrees can be broken up into smaller pieces called minutes. Sometimes if you've been listening to a show, maybe you have heard somebody say the latitude is 58 degrees, 12 minutes. Because degrees can be broken down into these smaller pieces called minutes. And the minutes can be broken down into smaller pieces called seconds, just like the hours on a clock. So you can think of a degree as an hour, and it is broken up into 60 minutes, and each of those minutes is broken up into 60 seconds. In the old days, we had to do that by hand. Don't you feel sorry for me? I had to do all that by hand. All you're going to have to do is push a button. So here's what I want you to do. First thing, go to mode, and make sure that degrees is highlighted. Mode, in the top row buttons there, make sure degrees is highlighted because we are working with degrees. Everybody got it? Okay. Now, I want you to type in 100.4. Just type in 100.4. That's the problem. That's why I'm typing that in. That's the problem. Okay, everybody caught up? Because now here comes the new part. You have in the third row of buttons, the second one over, you have a button called apps, but right above it, you see it says angle. Everybody following? So I want you to press second angle, or second apps. And I want you to go all the way down to number 4 that says DMS, which stands for degrees, minutes, seconds. Press enter 2 times, and it tells you you have 100 whole degrees, which you knew that. You have 24 minutes and 0 seconds. Let's try the next one, see if you remember how to do that. So we type 18.375. Just type 18.375. Now go to your angle menu, which is second apps. Click down to DMS. And what'd you get this time? 18 degrees, 22 minutes, and 30 seconds. Are you getting that? All right, try the last one on your own. Negative 20.42 degrees. Don't let the negative bother you. Go ahead and type it in. Negative 20.42 degrees. Somebody said it's cake. Yeah, it's all cake. The whole class is cake. Pay attention. Negative 20 degrees. What'd you get? How many minutes? 25 minutes and 12 seconds. Perfect.
What was your grade last month?
Now, obviously that is cake, but it's only cake if you have a calculator. Trust me, if you don't have a calculator, it's not cake. All right, now we're going the other way. Now we have been given degree in problem A, 4A, we've been given degrees in minutes. Do you see that? And I want the decimal degree. This is called a decimal degree. It has a decimal point in it. This is degrees, minutes, seconds. So we know how to get from here to here. We use our DMS button. Now we're going to go the other way. We're going to take 132 minutes and 132 degrees and 11 minutes and change that back into a decimal form. Okay, ready? Here we go. I want you to type 132. Whatever the first number is, just type that in. Now go back to your angle menu, second apps. And you notice that number 1 is a degree mark? Press it. So now your calculator says this. Now type 11. Then go back into your angle menu. And number 2 is your minutes. Press equals. And what did you come up with? 132.183 repeats over and over again. That didn't seem too bad. Let's try the next one. Okay, so pay attention this time. If you missed that first time through, pay attention. Here we go. All right, so we start by typing in what? 18. Quincy, you need to pay attention. You act like you're tired. You had 2.5 weeks to sleep.
I do.
18 degrees. Okay, so I typed in 18. Now where do I go? Second angle and press enter. That's your degree mark. Then we put in 12. Second angle. That's your minute mark. And then I type 13. There's no second mark. You're not going to believe this. I don't understand it. It's the weirdest thing in the world. You got 13 typed? To get your seconds, look clear over at your plus button. In green, or at least on my calculator it's in green, do you see the second symbol above the plus mark? So you need your alpha plus, and that will pull your minutes or your seconds in for you, and press enter. 18.20361 repeating degrees. Okay, we're going to go through it again. All right? Huh? I don't think so. I think it's probably right above the plus mark.
Push alpha, not second.
No. Alpha. It's green. It's green button. So you have the alpha. It's green. Okay. Now, let's try one more. Negative 152, the negative doesn't matter, just type it in, it doesn't matter a bit. 1839. All right, so if you were confused, listen carefully because this is the last one. All right, everybody ready? We're going to type negative 152. Go into second angle degrees. 18. Second angle, click down to minutes. Now, 39. I don't go to second angle, I go to alpha plus. And you should have gotten negative 152.3108 repeating threes. Okay, everybody get that? Okay, if you're not getting that, we're moving on now to something different. So if you're not getting those things, you need to get in here before school with your calculator, and I won't press the buttons for you, okay? But we're moving on now to something else. That's just a little calculator practice. Obviously, you have to have a calculator to be able to do it. So start bringing your calculators. Number 5. You're thinking, when you look at problem number 5, what in the world is going on? I'm going to give you a little hint. Arc length equals radius times radians. Now, for those of you that look in your book and read your book and look at the examples, they will write this like this. But what that means is arc length is the radian measure of the angle times the radius of the circle. So I have drawn a circle for you, and I've labeled everything so you know what's what. In our first problem, the radius is 10, the angle is 2, and your job is to find the arc length. Your book uses S for arc length. Okay? Using the formula, that's easy. What does arc length equal? Arc length equals radius times radians. So the answer to the first question is 20. This is the arc length, the length of the arc. So if I would have been more careful when I wrote the notes, I would have said maybe this was 10 inches, then this would have been 20 inches. It's an arc length. It's a unit of length, inches, feet, miles. It's a piece of the circumference. Isn't that easy? Let's look at the next one, see if it's easy. B says theta is 1.5. Theta is the angle. Look at my diagram there. Theta is the central angle. The arc length is 6, and we want to find the radius. Here's our formula. Can we do that? Arc length equals radius, which I don't know, so let's put R, times radians, which is 1.5. Remember, radians are the central angle. So what do? Divide by 1.5. And the radius of that circle is 4. So again, if this arc length had been 6 centimeters, then the radius would be 4 centimeters. They have the same length unit. This seems so easy. We love trigonometry. Next, we got an arc length of 10, a radius of 4, and we need to find the central angle. Can we do that? Sure we can. arc length equals radius times radians. I'll use theta because that's what I got on the paper, but if you want to use x, if it's easier, it's up to you. So what do you need to do? Very simple. Divide. So we get 10/4, which we will reduce to 5/2. That's it. It's that easy. Until we get to question D. And now I have, of course, tricked you. What is different? Here's your formula. Read your formula again. Arc length equals radius times radians. What's different about question number D? It is in degrees. So guess what we have to do before we even start the problem? What do we have to do? Change the degrees into radians. And that's the very first thing we did today. Pi over 180 equals something over 30. 30 degrees is your angle. I need to know how many radians that is. So I find the number of radians by doing pi over 180 equals x over degrees. So what does that work out to be? 30 pi over 180, which is pi over 6 if we take it all the way down. You're not done. You're not done. What you just figured out is this angle is pi over 6. You already knew the radius was 10, and now you're going to find the arc length. That's what's going on in question D. Okay? So here we go. Arc length equals radius times radians. That's my formula. Arc length equals radius times radians. So that's 10 pi over 6. Remember, when you multiply fractions, kids, it's top times top, bottom times bottom. So I got 10 pi over 6, which I'm sure reduces to something. 5 pi over 3. That's your arc length. Get comfortable with pies, kids. They're all over the place. So again, if this had been 10 feet on the radius, this would be 5 pi over 3 feet. All right, one more. One more. All right, here we go. Oh shoot, look, we have the same problem, don't we? In problem E, what's wrong with it? Here's your formula. What's wrong with it? It's in degrees. Can't be in degrees. Gotta be in radians. Gotta be in radians. So we start by saying pi over 180 equals something over 90. What's that work out to be? 90 pi over 180. Some of you are absolutely flying through this. Pi over 2, good job. So your central angle is pi over 2. What else do I know? My arc length is 10 pi, and I want to know my radius. You can't even be confused here, people. The formula is so easy. Arc length equals radius times radians. Now don't panic. You know how to deal with this. We need to get rid of this guy, right? So you might say I'm going to divide by pi over 2, which is fine. But what happens when we divide by a fraction? 10 pi divided by pi over 2 is the same as 10 pi times 2 over pi. Right? We multiply by the reciprocal. Now, this is a fraction of timesing straight across. So we have 20 pi over pi. That's what I got. Is that what you got? What is that? 20. The answer is 20. All right. Somebody say you have a question? Okay, we got 2 more problems to do, and then I will let you go. Number 6, using the compass on page 357. All right, so let's go to our books. Oh, 357. Now, basically, the compass on page 357 is a regular compass. I mean, like, if you are hiking in the woods, like you would have a compass. So, on your compass, this is east, north, west, and south, right? Everybody knows that? And this, if we drew one right straight there, that would be called northeast. Correct? Now, here's the part you might not know. If you split this difference here, this would be called north-northeast, and this one would be called east-northeast. Now, here's the deal. This is the northeast line, right? Everybody understands that. This is on the north side of the northeast, and this is on the east side of the northeast. Okay, so let's say I split this one. What would that be? Southeast. But now when I split this one, I'm on the east side of southeast, and here I'm on the south side of southeast. You getting the picture? That's what's drawn in your book. So if you don't have a book, this is what's drawn with all the rest in. Now, here's what this question involves, you knowing. Obviously, in the beginning, north and east are making a right angle, right? So that's 90 degrees right there in that quadrant. When you drew in the northeast line, you split that. So this here is 45. Agreed? And then when you drew that one in, you split that, so it's 22 and a half. So each of these little guys are 22 and a half all the way around. They're 22 and a half all the way around. Does that make sense to you? So when it says on the paper, east, southeast, find the angle measure that describes the following directions. Oh, there's one more piece of information I need to give you. And it is not given on the compass in the book. North is 0, east is 90, south is 180, and west is 270. That's the way a compass is set up. Right? I didn't make the rules. That's just the way it is. Now, I want east, southeast. So I want to know what angle that would be. Now, north is 0, east is 90. So I'm going how much more? What did we say this was? 22 and a half. So this guy right here, this angle right here, east, southeast, is going to be 90 plus 22 and a half. So 112.5 is east, southeast. Southwest. Next question. Southwest. I don't have it drawn. This is southwest. Would you agree with me? Now, I do know that all the way to here would be 180. And then how much more is this? 45. So this would be 225. 180. South is 180. And then I'm going halfway to 270. So it'd be 225, 45 extra degrees. West, northwest. I don't have that one drawn either, so I have to draw it. So here's northwest. Here would be west, northwest. This would be north, northwest. Now I want to know what angle this is right here, west, northwest. Well, how far is it all the way to west? 270. And then how much more do I go? What's my little split here? 22 and a half. So 270 and 22 and a half would be 292.5. Last one, north, northwest. Now north, northwest goes all the way around except for this part, right? So could I do 360 minus 22 and a half? Would that be one way of figuring that out? Maybe the easiest way? So what is that? I need help. What is that? 337.5 would be north, northwest. All right, one more, and then we are done with this section. Okay, here we go. Ready? A ship leaves port and travels 15 miles. Okay, so now you need your compass on a course of 100 degrees. Okay, now wait a minute. Where would 100 degrees be? Remember, east is 90. So wouldn't 100 degrees kind of look like this? You're not going to get it exact, and that's okay. But would you agree 100 is about there? Okay, so there he goes. And he traveled 15 miles. So I'm going to make that a 15. 15 miles. Now he changes course. So now he's here. I'm going to put another compass here. And it says he goes on a course of 200 degrees. All right, now wait. 200 degrees would be where? Down here somewhere? So now he's turning like this. This is 200 degrees. So he went 15 miles in this direction. And then he went 2 miles in that direction. So now he's right here. Now it says draw a sketch of the journey. That's it. If you are uncomfortable with all of the compasses and all that in there, what it really looks like is that right there. There's a picture of his journey. 15 miles that way and 2 miles that way. Wait a minute. Are you ready to leave?
We're not ready, but...
All right, now this is a lunch period, so if you have first lunch, you're going to lunch. Otherwise, you're going to eat. I'll see you.